Hello everyone, in this video I'll show you how to advect a texture using Procedural Fluid Simulator of geometry nodes in Blender 4.3. The setup is really simple and general. With this you can advect a texture on any grid, curve-based grid or any 3D surface. Let's get started. First we're going to advect the texture on a grid fluid simulator for the grid, and then I'll show you how to advect the texture on the 3D surface. Okay. And I will also show you how to enhance and preserve the details of the fluid on a low resolution grid or low resolution mesh surface. So let's add this into our scene. If you have assigned the fluid simulator as an asset library, then you can easily add these assets from the asset browser. Okay, let's go to the geometry nodes. Now if we run the simulation, see, the color from the object as well as the color of this grid is advected with the fluid motion. In our case, we don't want to advect the color, we want to advect the texture. So for that we have to advect the vector that we can use as vector coordinates for the image texture. Okay. In the grid setting, you can specify the resolution as well as the size of the grid according to your texture. In the initialization, we don't need this checker texture. So let's disable this option and enable this option, advect vector. And here we need to specify the vector that we want to advect with the fluid. So in this case, we want to advect the UV vectors of the grid. Okay. In the internal settings, you can specify the viscosity and other parameters for the fluid. And in the external, we can delete this and also disable this option because we are not advecting the color. And here you can specify the velocity and forces for the fluid. Okay, so there are different forces nodes available for this. Okay, so you can utilize them. And next is the collision. For the collision, you have to add the collection that contain the objects for the collision. Okay, so in this case, we have this icosphere that is colliding with this grid or the fluid. So here you can specify the velocity if it is animated. Like in this case, it is moving. So you can specify the positive velocity. It is going to push the fluid along its motion. If it is negative velocity, then it is going to push the fluid backward with respect to its motion. Then you have other settings like displace and material. Okay. To see this vector, advect vector, we can use the fluid info node. This is the advect vector. Let's connect that. We have this. Now let's run the fluid simulation. You can see that it is advecting the vector. Now let's add a texture to this grid so that we can see that in practice. So let's delete that and go to the material, go to the top mode. And if you select this grid, it has two materials. One is for the fluid and the second one is for the fluid particles. In this case, we need the fluid material. It also comes with this fluid info node for the material. And you can also add that from this. Okay, now let's disconnect that and press Ctrl T to add this setup. And let me delete this because we're going to use our advect vector as a vector coordinates for the image texture. Now let's add the image. Let's use this one. See, it is advecting this texture with the fluid. And another thing probably you need, that is the advection mask. So that you can easily get by taking the distance from the advect vector and with the UV vectors. So this will give you the advection mask that you can utilize to control different parameters of the material. Okay. Now let's go to the geometry nodes. Here I want to change one thing, that is the velocity scale. So I want to slightly increase that so it create a really nice push effect, like it is pushing through the texture and the texture is pile up in front of this sphere. See this. So it has two problems. The first is these vectors are not smooth. Okay, so we have to smooth them. And the second is we have to enhance or preserve the details while smoothing these vectors. So let's first bake the simulation. It is baked. Now we're going to add the store named attribute node change that to vector and select this Advect Vector. Then we're going to add the blur node, and after that we're going to add the named attribute node and type this name Advect Vector. Now if you increase the iterations, we can smooth these vectors. But with this, we have lost some of the details of the fluid motion. So to preserve that and enhance that, we're going to subdivide the mesh before this smoothing operation. And let me make this level 2. See, now if I mute this, see, it is not affecting the details of the fluid. Okay. And in the material, you can use the image sequence as well as a video for the advection. So this is the complete setup to advect any texture with the fluid simulator of geometry nodes. Now I'll show you how to advect texture on a 3D surface. We have this example. In this example, I am advecting the texture onto the icosphere using fluid simulator for the mesh. First, I have stored the UVs and then input that UV for the advection. Enable this option, and the rest of the settings are same. In the collision, I want this collision object should push the fluid in the backward direction. Okay, so I make this velocity negative. Okay, now to preserve the details and to smooth these vectors, I have to use a different method, because if we subdivide this icosphere, it has triangular faces. So that will not give you a nice result. What I have done, I have first simulate the fluid simulation onto a icosphere that has low resolution, and then I have transferred that data to a high resolution icosphere or high resolution mesh. After that, I have baked the simulation and then smooth the advect vector. The main idea is if you want to advect the texture on any 3D surface using fluid simulator for mesh, you create two models. One is low resolution and another is high resolution. You simulate the fluid motion on a low resolution and then transfer that to a high resolution mesh. So in this way, you can efficiently bake the simulation. And this is the material for this. This is it. I hope you learned something from this video. The project files are available on my Patreon page. If you have any query or doubt, you can ask me in the comment section or you can ask me on my Discord channel. So thank you for watching. See you in the next video. Happy noding. Bye.